In this video, we're going to take a look at solving absolute value equations. So let's follow these 4 steps. We're going to get the absolute value symbol by itself by moving any numbers around it by using inverse operations. We're going to set up 2 equations, one positive and one negative. We're going to solve each equation, and then we're going to check our solution by either plugging it in to the original equation, or we can type it into Desmos and see where it crosses the x-axis. Okay, so let's get started. For example 1, the absolute value symbols are already by themselves, so we can go ahead and set up our 2 equations, one positive and one negative. So x plus 2 equals positive 6, and x plus 2 equals negative 6. So then we need to solve each equation. So I'm going to subtract 2 from both sides, and I get x equals 4. And I'm going to do the same thing over here. But when I subtract 2 from negative 6, I get negative 8. So I can either plug those back into my original equation and check it, or I can check it in Desmos, which is a very quick way to just check and make sure I've got the right values for x. So let me show you over here. So if I type this one in, I want to type in the absolute value, of x plus 2. And I can type it like it looks. It's just going to look like these bars that cross through the negative 8 and the 4. But what you can do is move the 6 to the other side is another way to check your answer, and it'll look a little bit better. And so if I just scoot the 6 over, I can click on my x-intercepts, and I can make sure they are at negative 8 and 4. So with just a little bit of work, I can check it. So let's look at number 2. Let's clear that one out. We have the absolute value of x plus 2 equals 6. So the absolute value of x is not by itself. I've got this plus 2 over here that I've got to get rid of. So first things first, let's subtract 2 from both sides, and then the absolute value of x will be by itself. So bring that down, and then the 2 goes away, and 6 minus 2 leaves me with 4. But now the absolute value symbol is by itself, so I can set up my 2 equations. I have x equals 4 and then x equals negative 4. But notice there's no more work involved for this one. So you're finished solving. Let's check it. So we have the absolute value of x plus 2 equals 6. Notice it does touch at 4 and negative 4. That's one way to check the answer. Or if I just subtract this 6 to the other side, then I can click on it and it'll show me the numbers 4 and negative 4. And so let's just put a little check. We have checked these. They definitely both work. Let's look at another one. So number 3, the absolute value symbol is by itself. There's nothing else before we get to that equal sign over here. So we can go ahead and set up 2 equations. Let's say 2x plus 5 equals 9 and 2x plus 5 equals negative 9. And then we just need to solve each equation. So I'm going to start by subtracting 5. So then 2x equals 4, and then divide by 2, and we get x equals 2 for one of them. For the other one, I can subtract 5 again, so I get 2x equals negative 14, and then divide by 2, and x equals negative 7. So once again, let's just check it with Desmos. So 2x plus 5 equals 9. And you're just checking to see if it crosses through those values. So negative 7 and 2. And if you like to click on the numbers, you just got to subtract the 9 over to the other side. Then when I click on the x-intercepts, I can easily see that negative 7 and 2 are both answers and they both work. Nothing extraneous. So number 4, I can see the absolute value symbol is not quite by itself. We've got this 4 out front. So let's start by getting rid of it. So it's multiplying when it's just sitting out front like that. We need to divide because that's the inverse operation for multiplying. So bring down the absolute value of 2x minus 6 equals, and then you have 32 divided by 4 is 8. Notice I have not taken away the absolute value symbol yet. It's important to keep it to make sure you've now got it all by itself. So I can see now that it's by itself, I want to go ahead and set up my 2 equations. So let's set up the positive and the negative equation. So 2x minus 6 equals positive 8, and 2x minus 6 equals negative 8. Because remember, what's inside of here can come out as positive 8, because 8 is 8 units from 0. But negative 8 is also 8 units from 0. And we don't know which one it is, so we have to use both to figure out what possible values of x would work. All right, so let's solve the equations. We're going to add 6, so we get 2x equals 14. Then we divide by 2, and we get x equals 7. We're going to add 6 over here to this side, so we get 2x equals negative 2. When we divide by 2, we get x equals negative 1. Then let's check our answer. So just first type what you see on your paper, just like it looks. You haven't changed anything yet. And you can check it the first way. I can see that it touches at negative 1 and at 7. But then if I want to scoot the 32 over, again, you can click on these values and make sure they are what you've got. So let's put a check that we have verified those and look at one more example. So this one certainly looks like it has a little more personality down here. We've got 7 and then the absolute value of 8 minus 3x. So the 7 is going to need to move. Then on the other side, we've got 21x minus 49. So let's divide everything by 7 first, because we've got to get the absolute value by itself before we do anything else. That is very important. So then 7 will go away from the left side, and we have the absolute value of 8 minus 3x equals 3x minus 7. All right, so now that I have the absolute value by itself, I can go ahead and set up a positive equation and a negative equation. Same way we normally do, but watch this one a little more carefully. We have 8 minus 3x stays the same, and then that's going to equal a positive 3x minus 7. So we did not really change any signs on that equation. But the negative equation, we're going to have 8 minus 3x stays the same, but change both the negative 3x and the sign on this 7. Like, change both signs of this side, and that's going to give you the right answer. And then we solve from there. So I see that I have x on both sides, so I'm going to add 3x since negative 3x is smaller than 3x. And that gives me 8 equals negative 7, which does not make good sense. So 8 is not equal to negative 7. And so in this case, or excuse me, I take that back. That's why that one's looking a little strange. We have 8. These 3x's cancel out, and I'm sorry, 3x plus 3x would add up to 6x. So let's bring down 6x minus 7, and then add 7. I was wondering why that was looking so strange. So 15 equals 6x. We can divide by 6, and we get x would equal, and then let's just reduce 15 over 6. They both divide evenly by 3, so we can reduce it to be 5 halves or 2.5. All right, now let's look at the other side. Let's add 3x over here. And in this case, they do cancel out. So on one side, it does end up being an extraneous solution, or like whatever value that would have turned out to be would not make any sense. So let's check our answer and see if it matches up with what we found. So we have 7, the absolute value of 8 minus 3x equals 21x minus 49. So notice on this one, we only have one solution, and it does look like it's at 2.5. And if you want to check it the other way, you just have to move both terms over. So change their sign, and then you can click on it and see that it does touch at 2.5. So this answer just doesn't make sense. There would be one solution only. So let's just write only one solution. So sometimes there are 2 solutions, sometimes there's 1, and sometimes there are no solutions. So you do need to check your answers to make sure that what you have is correct, because it's not always going to have 2 solutions. All right, so that's it for solving absolute value equations.